Bismillahirrahmanirrahim. The current voltage characteristic, which is referred as the IV characteristic of a diode, illustrate how the current passes through the diode varies with the applied voltage across it. This relationship is fundamental to understanding diode behavior in different circuit conditions. Here's some detailed overview of their current voltage characteristic, which also define the electrical response of a diode. The IV characteristic curve of a diode can be divided into two regions. One is forward bias region, where the diode is forward biased, positive voltage applied to the anode relative to the cathode. It's began to conduct. Threshold voltage, which is the voltage at forward bias, voltage drop. Initially, there is a little or no current until the voltage exceeds a certain threshold known as a threshold voltage or forward voltage drop. For silicon diode, this voltage is typically around zero point 0.6 to zero point 0.7 volt. For germanium diode, it's about zero point 0.2 to zero point 0.3 volt, and their value varies depends on many other factors. After the threshold, the current increases rapidly with a small increase in voltage, indicating very low dynamic resistance. Another region is reverse bias region. In reverse bias region, the diode is reverse bias mode, which means that positive voltage on the cathode. It blocks the current flow. A small leakage current known as reverse saturation current is still flow, but their typical value is microampere range or even nanoampere range. It also defines the quality of diode. If the reverse bias voltage exceeds a certain level called reverse breakdown voltage, the diode will begin to conduct significantly in the reverse direction as shown that current is sharply increases. This can be damage for regular diode, but Zener diodes are designed to operate safely in this use. The current voltage characteristic of diode also be discussed with quadrant representation. The IV characteristic curve is usually present in the first and third quadrant of a Cartesian graph as shown in figure C. The x-axis represents the voltage, while the y-axis represents the current. The threshold voltage, also referred as a forward voltage drop, is the minimum voltage that must be applied across a diode in the forward direction for it begin conducting significant current. This value influenced primarily by the semiconducting material itself and some other factor we will discuss in detail. But below is the detailed explanation of threshold voltage for different material. Germanium-based diode, their threshold voltage approximately zero point 0.2 to zero point 0.3 voltage, and germanium diode have a very low forward voltage drop compared to silicon diode as well as gallium arsenide based diode. Due to small voltage, they are highly sensitive to temperature changes, meaning their forward voltage drop can decreases with increasing temperature. Due to their lower threshold voltage, germanium diodes are often used in low voltage application and radio frequency circuits. Silicon diode threshold voltage approximately zero point 0.6 to zero point 0.7 voltage in most of the semiconductor devices. Silicon diodes are the most commonly used type of diode in modern VLSI and ULSI circuits. They have a higher forward voltage drop as compared to germanium, which make them suitable for wide range of applications, including power supplies and rectifiers. The higher threshold voltage also contributes to better thermal stability compared to the germanium-based diode. Silicon diode exhibit a more pronounced exponential increase in current with voltage once the threshold is surpassed. Gallium arsenide In gallium arsenide, threshold voltage approximately zero point 0.8 to 1 volts, and this voltage is relatively very high compared to germanium and high with compared to silicon. Gallium arsenide diode offers high performance in high frequency application due to their superior electron mobility. The high forward voltage drop compared to silicon and germanium make them less common for standard rectification devices, but advantageous in optoelectronic devices like light and laser due to the direct nature of energy band amplitude. Gallium arsenide diodes are often used in high speed and high frequency applications due to their ability to operate effectively at higher speed. Variability in threshold voltage is some serious issues for designing the semiconductor-based devices where PN junction involves. The threshold voltage can vary based on several factors. Most important factor is diode design itself. Different design, for example, Schottky diode, Zener diode, etc., can have different threshold voltage level due to their construction and intended application. Another important parameter for the variability in threshold voltage is temperature. As temperature increases, the forward voltage drop typically decreases for all diode types, affecting their performance in high temperature environment. Doping level is another important issue for variability of the threshold voltage. The level of the doping in semiconductor material can also influence the threshold voltage. Higher doping concentration can lead to the lower forward voltage drop. Thank you.